During a gold rush, it is a good idea to be in the business of selling shovels. And technology investors seem to agree, as they've been falling over themselves recently to invest into the current vector database boom. The deals have been coming thick and fast. Pinecone, a cloud vector database provider, was recently valued at $700 million, with Chroma and Weaviate also bagging funding rounds, putting their valuations in the hundreds of millions. So, what is a vector database? The first point to note is that modern AI makes use of huge amounts of unstructured data, like images, audio files, and videos. This data is fundamentally different from traditional data, such as customer addresses, for example, which are more structured. Traditional structured data fit easily into traditional SQL-based databases, since they can be easily organized into rows and columns. How would we meaningfully organize unstructured data like images into neat rows and columns? Traditionally, we have relied on tags, which might reflect the content of the video, for example. Vector databases, however, offer a very different approach to storing unstructured data. They store a numerical representation of the contents of the file, called a vector embedding, which represents the semantic meaning of the file. Embeddings can be generated using AI models from companies like OpenAI. Each file is represented as a point in multidimensional space. Points representing similar contents are placed close to one another, while dissimilar data points are stored farther apart. In this image, for example, Tokyo is placed near Japan, and Rome is placed near Italy, as each country has a semantic relationship with its capital city. Storing relationships like this, based on vector embeddings, into a vector database allows rapid retrieval of files that are semantically similar to each other. And semantic search is rocketing in popularity. This slide shows the number of academic papers mentioning the term semantic search. The trend appears to be strongly positive so far. Vector databases, then, are so hot right now, as they are specifically designed to power a number of trending AI use cases. These include semantic search, searching based on the meaning of something rather than the exact string of text in the search query. Similarity search, which could power product recommendations based on historic purchases, for example. Anomaly detection and deduplication. Another key point that is powering the current vector database narrative right now is that they go hand in hand with one of the biggest AI current trends. Large language models, also known as LLMs, like ChatGPT. One of the big drawbacks of LLMs like ChatGPT currently is that they are subject to hard token limits, which restrict the size of the context or input data you can provide to the model. When GPT-3 was released, the limit for both the prompt and the output combined was around 2,000 tokens. With GPT 3.5, this limit increased to 4,096 tokens. Now, GPT-4 comes with a limit of around 32,000 tokens, enough to input around 50 pages of text. But what if you want to search an 800-page programming book or a Harry Potter book using ChatGPT? At 800 pages, that would equate to around 700,000 tokens. That's going to break things. One current smart trick is to embed and store the book in the vector database, then convert your search query to a vector embedding, and search the database for similar embeddings before feeding the results into your LLM prompt, which then finally replies to the user. Vector databases can also be used to provide long-term memory to your LLM model, making you more powerful than Thor himself. So with vector databases being so hot right now, what are the big names you should check out? Ash_CS on Twitter put together a nice summary of the pros and cons of the current vector database suppliers. These include Pinecone, Chroma, Weaviate, Milvus, and also vector stores from more traditional suppliers like Redis and Postgres PG Vector.
So, now you know what a vector database is. Go forth and build!